Okay, so let's look at what we've got. The first problem, and like I said, as we go over it, just make notes on here, because we will re-quiz, and hopefully this will help. So on the first one, it said, a computer performs a calculation of 2.5 times in 2.5 times 10 to the negative 5 seconds to solve a math problem. So that's its speed, okay? That's how fast. It says, how long does the computer need to calculate the solution to 3 times 10 to the 6th math problems? What number is 3 times 10 to the 6th? 3 million. Yeah, so we're looking at how long is it going to take this computer to calculate 3 million problems, which that seems like a huge amount of problems, but you have to think about it's only taking the computer this long to solve one math problem, so it's not really going to take that long. But if this is its rate and this is how many I have to do, what's going to be my operation for this? I'm going to multiply, because it's like if this is your speed, okay, this is how fast the computer's doing it, you have this many of them, so we're multiplying. So 2.5 times 10 to the negative 5 times 3 times 10 to the 6th. All right, so what's our rule when we're multiplying numbers in scientific notation? Do the exponents have to match? No. So we're not going to match the exponents, so then we go back to our exponent rules. When we're multiplying with the same base, what do we do with the exponents? Add. So we know that part of our answer, what is negative 5 plus 6? 1. So we know we're going to have something times 10 to the first. That part we can take care of. And then all I've got to do is multiply 2.5 times 3. Well, what is 5 times 3? 15, carrying the 1. 2 times 3, 6 plus 1 is 7, and you've got one place behind the decimal, so I'm counting over 1. So 7.5 times 10 to the first. And if I expanded this out, I think your quiz left it in scientific notation, maybe? Did it expand it out? Okay, so if we expand it, what would this be? Yeah, so it's going to take 75 seconds, which is not long, like a minute and 15 seconds, to do 3 million problems, which is pretty awesome. I wish I could do 3 million problems in a minute and 15 seconds. Okay, let's look on to the next one. It says, the table shows the number of bottles of hand soap sold each month for the first quarter of the year. Tell whether each statement is true or false. So you had like 4 little mini problems to do in here. So the first one, it says 3,260 more bottles were sold in February than January. So what are we going to have to do to find this? Well, we could, but I don't think I would bother. How many of y'all took them out of scientific notation and then worked it? I don't think I would bother. I think I'd just work the way they are. Now, what I think I would do is, if this is the only one that's different from these two, I probably would have changed this one for the exponents to match, so when you do get down to working with it, you don't have to worry about doing that. I would do that. So if I need this exponent to go to a 3, which way does the decimal go? To the left or to the right? To the right. To the right decreases the exponent, to the left increases. So this could be rewritten as 10.89 times 10 to the third. I could do that. But let's go back to our problem. It says more bottles February than January. So what are we doing to February and January? We're subtracting. And I've already made their exponents match. So all I've got to do is 10.89 minus 7.63, because I know it's going to be times 10 to the third. I took care of that. What is 9 minus 3? 6. And 8 minus 6? And 10 minus 7? 3. All right, it says 3.26 times 10 to the third. Is that 3,260? Yes, because if we move that decimal 3 places to the right, we do get 3260. Okay. All right, then let's look at B. 631 more bottles were sold in February than March. So more February than March. So now we're doing what with February and March? Subtracting again, and I've already made a match, so let's keep with that. So we're going to have our 1089 minus our 458. Okay, so we'll get 6.31 times 10 to the third. All right. Is 6.31 times 10 to the third 631? No, because that would actually be 6,310. So that's a false. All right, what about C? 305 more bottles were sold in January than March. So yeah, now we're working with the January and March subtracting. I'll just do it out here to the side. So 7.63 minus 4.58. So I got 3.05 times 10 to the third. Is that 305? No, that's 3,050. So that's a false. And then D, and remember, you're writing everything down I'm writing down. Are you doing that? Mm-mm. That's why you should be writing the math down. We're not. These are not solving your head problems. These are do the math problems. All right, and then D says 23,100 total bottles. So total means we're going to do what? Add up all these numbers. And we've already made them the same exponents. So we're just going to take our 7.63, our 10.89, and our 4.58. Bless you. And all of that is going to be times 10 to the third. So we're looking to see, is it 23,100? So 3 and 9 is what? Plus 8 more? So 20. All right. 6 and 8 is plus 5 more. And 19 plus 2 is 21. All right. 2 and 7 is, and 9 and 4 is 13. And then 2. So I've got 2310 times 10 to the third. Is that 23,100? Yes. Because when you move that decimal 3 places, that's a comma, you'll get 23,100. So yes, that is true. All right, questions on any of those? And you could have, like he said, he went ahead and just expanded his and made them big. And these weren't too bad to do that because their exponents weren't really large. But the beauty of having it in scientific notation is you're working with lots smaller numbers than all those big ones, so you don't get lost in the zeros. Okay, but these weren't too large, so they've been okay. All right, let's look at the bottom one. It says that light travels at approximately 2.998 times 10 to the 5th kilometers per second. So that's our rate. We looked at one like that the other day. We said if it's kilometers per second, miles per hour, feet per minute, whatever they're giving you, that's a rate. It says there are 6.048 times 10 to the 5th seconds in 1 week. So that's our time. and it says about how many kilometers does light travel in 1 week. Well, obviously we're going to get 1.813 as our part of our final answer, but we've got to do a little more work than that. We're really multiplying 2.998 times 10 to the 5th, because that's our rate. We mentioned the other day, let me back up. We said the other day, when you have rate and time, you're really using your DIRT formula. Distance equals rate times time, because we're looking for the distance. Okay, so I've got my rate, I've got my time, and when I multiply them, I will get my distance, my kilometers. All right, what do we do? Let's take care of these exponents first. What do we do when we're multiplying with the same base? We add. So right now I've got times 10 to the 10th, so that's a possibility, but there's also an 11. So I've got to check the math. I can't just assume that it's the 10. So I'm going to do 2.98, and I'm going to write it right underneath since I don't have a whole lot of room, 6.048. Okay, that's what I'm multiplying. All right, so help me through it. What is 8 times 8? All right, 64. 4 times 9? Plus 6? 42. All right. 4 times 9 again, 36 plus 4 is 40. All right. Oh, did I miss a... Oh, let me back up. I've already messed that up. Let me grab a sheet of paper. I was trying to conserve space and I skipped a number. Did you catch it when I did it?
Yeah.
Well, you got to speak up. Y'all got to tell me. Let me grab a sheet of paper. Let's start fresh. So 2.998 times 6.048. That's why I should be using a pencil. Okay, so we said 8 times 8 was 64. 8 times 9 was 72. Plus 6 was 78. 9 times 8 was 72. Plus 7 was what? 9 times 8 was 72. Plus 7 is 79. All right, 2 times 8 is, plus 7 is 23. I think that's the hard part, too, for y'all in this quiz, because we put it, for you, we put it on lock mode, so you couldn't pull up the calculators, and I think some of you struggle with your multiplying and your dividing still. All right, so I'm going on to this next number, so the 4s. So 4 times 8 is 32. 4 times 9, there's my 4 and 9. It's 36 plus 3 is 39. 4 times 9 is 36 plus 3 is 39. All right. 2 times 4 is 8 plus 3 is 11. We've got the 0 coming there. I'm just going to fill in our spots so we don't have to worry about it. And then 6 times 8 is 48. 6 times 9 is 54, plus 4 more is 58. Again, 6 times 9 is 54, plus 5 is 61. All right. And 6 times 2 is 12, plus 2 is 18. I think I got them all. So 4, 10, 19, 21, 3, 8. Did I get it? Seems like I left a 1 out somewhere, because I know in the problem. But this is going to get me close enough. So I got 3, 6. So it'd be here. So I've got 18.33. These all have 1.8. So I'm not sure if that's a typo or if we missed it somewhere. But I got this in the last class too. Yes, Gavin?
Get the 9 wrong. The 9 plus 9.
Is 18 plus 1 more is 19?
I didn't see that one.
Yeah, there's a 1 up there. Yeah. All right, so, but the main thing is going to be our exponent. Is this decimal in the right spot? No. So when we move it to the left, what's going to happen to that exponent? It's going up. So we're going to have times 10 to the 11th, so we know it's going to be C. Okay. And that was really the whole purpose of doing all that math, was whether it was going to stay or move. Yes, Benny? I don't know if that's always going to tell you, though, where that decimal is going to end up, because if you had like just 6.48, our decimal would have been in a different place when we counted over from the end. You know, because the 0 didn't really change our number except for our decimal placement. So be careful doing it that way. I think it just kind of lucked out for you this time. So like I said, the 0 didn't change our value, it just changed our decimal place. Okay. All right. Okay, now this next one was pretty easy. It just said, what is the sum? What do we do for sum? We add. So what's the only thing I've got to do here before I can add? Yeah, I've got to make the exponents match. So do you want to go big or go small? Let's go big. You usually have to adjust the decimal when you go small, so let's go big. So which is bigger, -3 or -4? -3 is actually bigger. So to increase the exponent, which way is the decimal got to go? To the left. So that means this one's going to have to move and become 0.54 times 10 to the -3. So I have 2.3 plus 0.54. So that one wasn't bad at all. What'd you do wrong?
I would not choose
Oh, so you didn't make your exponents match? Okay. Yeah, so you probably picked C when you did it, maybe? Yeah. So yeah, exponents have got to match, and then you just keep that number. All right, now the next one was quite a bit of work, but we'll make it. It said, which pair of numbers in scientific notation show one number that is about 20 times as great as the other number? Now, does that mean that you have to divide in the order that they're given? No. It just means find the biggest number. Is it 20 times as much as the smaller number? Well, how do I find that? What are you going to do? Well, I do what? Oh, I wouldn't want to put these in standard form. No way. You got to divide, because they're looking at, is it about, and about is a key word, 20 times as great. So we're saying if I took one number, multiplied it by 20, would I get the other number? That's what it's asking. Okay. All right, so let's just look at them. We're just going to do it. It's a little bit of work, but we'll get there. All right, so let's look at the first one. Which is bigger? Which of these numbers? The 2 or the 4? Yeah, the 2.01 times 10 to the 7th is larger. How do we know that? Because the exponent. The bigger the exponent, the bigger the number. So that means that that number's going on top. So that's how I'm going to set that up, okay? Now, let's just go ahead and get the exponent part out of the way. What do we do with exponents when we're dividing? Subtract. When they're stacked, we subtract. So we already know we got something times 10 to the first, okay? So I've just really got to do my dividing here. So I'm going to do my 4.25 into 2.01. So we're moving it twice. So is 425 going to go into 201? No. All right, so think about where it's going here. How many times is 425 going to go into 2010? Yeah, 4 times. And if we do the multiplying, 4 times 5, 4 times 8, and 4 times 4. Okay. Now, let me ask you, we've got 0.4 and other stuff is coming, but it says times 10 to the first. That 1 means you're going to have to do what? Move the decimal 1 place to the right. So this is just going to be 4. So is this number 20 times as much as this one? No, it's only 4 times as much. So there's no point in even dividing out any further. Look at what the numbers are that you're getting. So no, I don't have to divide it on out. And I think that was a problem too. The people who knew how to do the problem, you were like dividing forever and ever, and you didn't know when to just stop and look at what you had. Save yourself some work. All right, so let's look at B. Same thing. Which number is bigger? The 5.97, because it has a bigger exponent. All right, so I'm looking at 5.97 times 10 to the 4th over 3.12 times 10 to the 3rd. All right, let's go ahead and take care of our exponents. We're going to end up with times 10 to the what? First, okay, because 4 minus 3. So let's check our dividing. 3.12 into 5.97. So does 312 go into 597? Yeah, it'll go in there 1 time. And then what about 312 into 1850? Or not 18, sorry, 2850. And remember I told you the other day the shortcut to try to kind of figure these out is think, okay, 3 goes into 28 how many times? How close can we get? How many? More. 9. So let's try the 9. I think we'll be okay. So 9 times 2, 18. 9 times 1 plus 1. And 9 times 3 plus 1 is 28. So, and we could keep going, but look at what you got. You got 1.9 times 10 to the first. What's that going to be when you expand it? It's going to be 19. Is that about 20? Yeah, because we're estimating it said about. We're not going to get exactly 20. We're going to get maybe 19, maybe 20, maybe 21. We're not going to be exact. Okay. All right, so let's check C. The 4.91 is larger. What's my exponent going to be when we finish this? Times 10 to the 3rd. All right, so I'm dividing out 5.06 into 4.91. All right, so let's use our shortcut. How many times does 5 go into 49? 9 times. So let's see if that'll work. So 9 times 6 is 54. 9 times 0 plus 5. And 9 times 5. And I could keep going, but look at what you've got. You got 0.9 something, something, something times 10 to the third. Is that going to work out to be 20? Or anywhere close to it? No. So I don't have to divide any further. That's enough to know. Yes, Benny? Yeah. I mean, that's definitely, what we're looking at is once you get it set up, is it going to be about 20 times? And like this one was 0.9, so there was no way it was going to work. So, but if you can look at those numbers, because D is going to work out for us, because look how we're going to set up D. Which number is bigger, the 8.21 or the 4.13? The 8.21, because remember, when they're negative, that's really bigger. So 8.21, and then 4.13. So now, what are these exponents going to do? What is negative 3 minus negative 4? One. Negative 3 minus negative 4 is 1. All right, so that's a good sign. And then we've got 8.21 and 4.13. I'll put it over here. And like Vinny said, 4 is going to go into 8, so this should be a good thing. All right, so now does 413 go into 821? Just once. Okay. So that gives us 408 when we subtract, and then 413 into 4,080 will go 9 times. Okay, so think about, you got 1.9 times 10 to the first. Is that about 20? Yeah, because that's going to be 19. So yes, that's going to work. Okay. And now the last one was a little trickier only because they didn't give it to you in the same order they've been giving it. Which number is bigger, the 2.94 or the 6.22? Yeah, the 6.22 is bigger. And this doesn't say you have to keep it in any certain order. It just says, is one of the numbers 20 times as large as one of the other numbers or the other number? Okay, it doesn't have to be the same order. So we're looking at 6.22. That's divided by the 2.94. So when we subtract these exponents, what are we going to get? What's negative 7 minus negative 8? 1. All right, so I really just got to do my 294 into 6.22. All right, and then does 200? How many times does 294 go into 622? Twice. So that's looking good. So we got 8, 18, and 5. And it's only going to go one time into that. So 2.1 times 10 to the first, is that about 20? Yeah. Okay. But there's a whole lot of math there to do. And I know when y'all were taking your quiz the other day, some of you were doing a whole lot of math and some of you were doing a whole lot of just mark an answer. You got to do the math, okay? Or at least have some idea of how these numbers are working together so you can eliminate some choices. All right, then this one, pretty easy after all of that. All you had to do was add and then divide. So before we can add, what have you got to do? Yeah, got to get my exponents to match. All right, so do you want to go big or go small? Go big. So that means this is really going to be 0.012 times 10 to the 17. So we've got 6.2 plus 0.012. So we have 6.212 times 10 to the 17th divided by 4 times 10 to the negative 6. So what about those exponents? Let's take care of that. What do I do with those? And what is 17 minus negative 6? How much? 17 minus negative 6. 23. Because remember, minus a negative is the same as plus a positive. So 23. All right, so let's do the dividing. So how many times does 4 go into 6? Once. All right, 4 into 22. 5. And 4 into 21. 5. And 4 into 12. 3. And if I remember right, on your quiz, all of the choices had 1.553. It was a matter of exponents, whether you picked that right or not, if I remember correctly. All right, how are we doing so far? Is this helping any at all?
Yes.
Okay, I hope so. I hope the scores are better tomorrow. That made me sad. Like, oh my goodness. Whew. All right. Yeah. Okay, this one says the volume of the planet Venus is about, and they give you that huge number. Who can say that number? All right, Will? Yes, 928 billion cubic kilometers. The volume of the planet Mercury is about 6.08 times 10 to the 10th cubic kilometers. What is the combined volume of Mercury and Venus? So combined volume means we're going to do what? Add. All right, Isaac, what is this 928? What is that big number in scientific notation? I have 9 zeros, but we moved it 11 times. Yeah, 11. So I'm actually adding these two numbers. Oops, sorry, you couldn't see that. But now, when I'm adding, what's going to happen? They got to match. So you can either go big or go small. I'm going to go big and make this one into 0.608 times 10 to the 11th. All right, so I'm really just adding 9.28 plus 0.608. Times 10 to the 11th. So you got C. All right. We good on that one? Yes, Benny. Will you be able to what? Use this? No. No, this is for you to use tonight to study for your quiz tomorrow, to look over it. Because y'all realize you could study for math quizzes, tests, just like you do any other subject. It's by, going back, look at your notes, do a few extra problems, look up some videos on YouTube or wherever and get like, oh yeah, there's some help. All right, then this one wasn't too bad. You just had to answer true or false. They're taking it from scientific to standard. So what does the exponent tell you when we're doing that? How many times to move the decimal? And if it's a positive exponent, we're moving it which direction? to the right, and if it's negative, we're moving it to the left. All right, so 4.25 times 10 to the 6, so it's moving 6 times to the right, so how many zeros will I need? How many? Yeah, 4. So is this correct? No. No. All right, 6.38 times 10 to the 9th. They've added 9 zeros. Is that correct? No. They should have only added how many? 7, yeah. All right, then C, 5.11 times 10 to the negative 2. They moved the decimal to the right. Is that correct? No. Supposed to move it to the left when it's negative. And 2.79 times 10 to the negative 4, did they move it negative 4 times? Yes. So that one they did well. All right. Now, I think this one, when you had it on the quiz, the confusing part was once it was wrong, people wanted to stop looking at it. But you're not checking the whole problem. You're just checking from one step to the next, because it says, which of Bethany's steps show an error based solely on her previous step. So once you've looked at A, you're looking at B, that's the only 2 spots you're looking. You're not looking at both. You got to start fresh every time, okay? So for step A, let's see what they did. They kept the 4 times 10 to the 11th. They kept the 3 times 10 to the negative 14. Did they do this one correctly? Is this 5 times 10 to the negative 5? Because they moved the decimal 1, 2, 3, 4, 5, 6 times. So no, that is not correct. Okay, that's what you were looking at. And then when you get ready to do B, don't think, oh, they missed A, so they missed it. You're looking at, okay, forget all of that happened, start fresh with this step. Don't worry about it was wrong once upon a time. You're just going from here to here. So they did the multiplying. 4 times 3 is 12. They said that 11 plus negative 14 is negative 3. Is that what you do when you're multiplying? Yeah. Yeah. And is 11 plus negative 14 negative 3? Yeah. And then they kept that. So B is okay. All right. Then C, they've moved, because they're going to add them eventually. So they first worked on this one. They moved the decimal to the right one place, and they have decreased their exponent. Is that correct? Yeah. If the decimal moves to the right, the exponent decreases. So they did that. Okay. And then this one they didn't do anything to. So we're okay on C. What about D? Where they're going from here to here. All right, they kept this part. They moved the decimal to the right. Did they decrease? They increased, because they went up to a negative 4. So D is incorrect. They should have made this a negative 6 if that's what they were doing. All right, and then from here to here, they added and got 170. Do we add exponents when we're adding numbers in scientific notation? No, we just keep them. So no, do not add the exponents. And then from here to here, they moved their decimal to the left 2 places. So did they increase by 2? Yes. So that they did correct. Okay. All right. And then this last one, it says the number of unique page views on a website is measured each day. The daily views are expressed in the table using scientific notation. So we got Sunday through Saturday views of the page. It says the number of views on the days with the most views is about how many times as great as the number of views of the day with the fewest views. So we said when you see the words how many times, what are you really doing? Dividing. So this is dividing. Okay. All right, so let's figure out what day had the most views. I hear Wednesday. All right, because we know it has to be one of the numbers with 5 as the exponent, and then 9 is the largest, so this is our biggest, so this is the most. All right, and then with the fewest, what's our smallest number? Yeah, the Monday, because now we're looking at the 4 exponents, and 2.89 is smallest. So that's our fewest. So we're doing 9.34 times 10 to the 5th divided by 2.89 times 10 to the 4th. All right, what do we do with those exponents when we're dividing? Subtracting. So we got something times 10 to the 1st. So let's just divide. Oops, that's a 9. So we're really doing 289 into 934. Well, and look at your multiple choice. Is it going to go 3 times, 9 times, or 1 time? 3 times, Miss Etheridge. Yes, you are right. All right, so 3 times 9 is what? 27. 3 times 8 is 24, plus 2 is 26. And then 3 times 2 is 6, plus that's got 8. All right, so I could keep going. I don't really have to, though, because it's 3 times, 3 point something times 10 to the 1st. What's that 10 to the 1st going to do for me? Yeah, we got to be doing 30. But if you missed that one, if you divided, you probably picked 3 just because when you were dividing, you forgot about, oh, we've got the power of 10. Okay?
This one, I got the dividing them. It's just when I was trying to fewest.
Yeah.
That's it.
Yeah. Yeah, you really got to read these problems and mark on it and see what you're doing wrong. Okay? All right, so look over this, study this. You will re-quiz tomorrow.